Hello everyone. Today I am going to discuss about the various methods to solve differential equations. The method to solve a differential equation depend upon the type of the differential equation. So here we are going to discuss the methods which are used to solve differential equation of first order and first degree. So these are the various methods to solve differential equation: variable separable form or reducible to variable separable form. The second is homogeneous or reducible to homogeneous differential equation. The third one is linear or reducible to linear form. And the last one is exact differential equation or equations which are reducible to exact form. So we will discuss all these methods one by one. So let's start with the first one, that is variable separable method. So as its name specify, in this method what we are doing, we are just separating out the different variables. So let's take the differential equation, say, which is of the form dy by dx is equal to some function of x and y. So if in this particular differential equation, if it could be represented in the form f of x multiplied with dx is equal to g of y multiplied with dy. If this particular differential equation can be written in this particular form, then after doing the integration on both the sides, we can find out the solution of the given differential equation. And this technique is known as variable separable method to solve the differential equation of first order and first degree. So let's take one example. This is, we are going to solve this differential equation secant square x tan y dy plus secant square y tan x dy is equal to 0. So clearly this is a differential equation of first order and first degree. So now let's check out whether it is possible to separate the variables or not. So clearly this equation can be written in the form secant square x dx is equal to minus sec square y dy, and here this is tan x and here this is tan y. So clearly in this equation we can apply the variable separable method, as here we have separated the variables of x on left hand side and here we have separated the variables of y on right hand side. So now just doing the integration on both sides, here we can find out the solution. So clearly integration of this term would be log of tan x, and here integration of this term would be log of tan y. So we know that from integration that when we are dealing with the definite integrals, we have to add one constant of integration. So here, rather than adding c, we will add log of c, because in the first and second term we are having logarithmic. So that's why we are taking log with the c, so that we can combining the terms easily. So now it can be written as log of tan y. Now, if you want to solve the differential equations, so you must be good in integrations. You can recall your concepts of integration from your previous classes. So here we know that log m plus log n, that is having a formula log m into n. So this is log c. So now what we can do, we can get rid of this logarithmic from both the sides. So this is tan x tan y is equal to c. So this is the solution of the given differential equation and this is the general solution. So in this way, by applying the method of separating the variables, we can find the solution of this particular differential equation. So let's take one more example to find out the solution of differential equation with the help of the same method. So this is the example 2. So here what we have to do, we have to solve this dy by dx is equal to y upon 2 root x. And this is given that y is equal to 1 when x is equal to 4. So that means in this question, after finding the general solution, we have to find the particular solution also, because these conditions are given. So let's start with the general solution first. So let's check whether in this equation we can separate the variables or not. So yes, it is possible to separate the variables. We can keep y on one side and we can keep x variable on the other side. So now it is possible to integrate to separate the variables. Now what we can do, we can do the integration on both sides. And by integration, we know integration of the left hand side is log y, and the integration of this right hand side would be root x, and this is plus constant of integration. So here, this is the general solution of this differential equation. So now some conditions are also given. The condition is y is equal to 1 when x is equal to 4. So let's make the use of this condition here. So y is equal to 1 and x is equal to 4. Put these values in general solution. Then log 1 is equal to root 4 plus c. So we know that the value of log 1 is 0. So this is 2 plus c. So this implies the value of c is equal to minus of 2. So we got the value of this constant. So that now we can find the particular solution for this question. This is, so this one is the particular solution of this given differential equation. So from the general solution using the given condition, we can find the particular solution. So this is the method of separating the variables to solve the differential equations. I hope this is clear to you.